Okay, in this video we're going to take a look at Ohm's law and kind of starting with a simple circuit that we built in class where we had a variable power supply and it was connected to different resistors, and we also had an ammeter set up built in that circuit to measure the current flowing through the circuit as we change the voltage. So let's say we were to increase the voltage and measure the current. And let's say we used a 1000 ohm resistor. What we would have gotten is some data like so. As we increased, and this is voltage in volts, current in amps, as we stepped up the voltage in half volt increments, we would have seen our current increase as well. And I'm just going to do a little bit of data there, not a full data. And if you would look at the trend here, as this goes up in regular steps of 1/2 volt, this goes up in regular steps of 0.0005 amps. So we would say that there is definitely a direct relationship here between V and I. So as we increase the voltage, we increase the current. Now if you were to plot this, or when you did plot something like this on your calculators in the lab, what you would have seen is, if this is 0.0005, 0.001, 0.0015, so forth and so on, and we'll go half volt, 1.0, 1.5, so forth and so on. The points would have created a straight line, increasing a linear direct relationship, and then we'd be calculating the slope of this, doing the regression. We would get rise over run, which in this case is my change in voltage between 2 points divided by my change in current. And if I look at from here to here, I go 0 to 0.5. From here to here, I go 0 to 0.0005. And if I calculate the slope, I would get a slope of 1000. Okay, so for a 1000 ohm resistor, when I plot voltage versus current and I find the slope is 1000. So that makes some connection. This slope here of the V versus I graph is the resistance of the circuit. So if we do some mathematical analysis using our slope-intercept formula, we know that the formula for a line is y equals mx plus b. So let's start with y equals mx plus b, where this is my slope, this is my y variable, this is my x variable, this is my y-intercept. And I substitute in for the variables that I have. I know my y variable here is voltage, V. Now my slope was 1000, which is related to my resistance. It is my resistance, the resistance of the circuit. So for slope, I'm going to call that R. My x variable I plotted was current. And the y-intercept here is 0, which can kind of go away out of our equation. And I'm left with this relationship V equals IR. And this is the relationship we call Ohm's law. So there's a couple ways to look at this. What we've said so far is as I increase the voltage, the current goes up as well. So there's a direct relationship between V and I. Well, there's another way I can look at this. What if I were to increase the resistance of my circuit, but I wanted to get the same current output? What would happen to my voltage? Well, let's go over here for a sec. If I put more resistance in the circuit, so let's say I go from, let's say 1,000 to say 10,000 ohm, what would have to happen to my voltage to get the same current? Let's just say a current of 1 amps. Well, if I go from 1,000 to 10,000, I've increased my resistance by 10. So I've increased that by 10. I want to keep I the same. What would I have to do to my voltage? Well, if I've increased this whole side by 10, I would have to apply 10 times as much energy or voltage into the circuit. So as I increase resistance, I would have to increase the voltage. Therefore, V and R are also directly related. So the more resistance in my circuit, if I want to get the same amount of flow, I got to apply more voltage. That should make sense conceptually. Now let's look at the other one. Let's go over here. So here's one relationship. Here's the other relationship. Let's look at what's the relationship of I versus R. Okay. So again, let's start with Ohm's law. Now this time, let's say I have a 3-volt battery. Here's another way you can look at these. I have a 3-volt battery, and I go from, let's say let's try to keep this simple. So let's say I have a 3 ohm resistor and I go to a 6 ohm resistor. So I double my resistance. Okay? What happens to my current? Well, in the first scenario, if I have a resistance of 3 and a voltage of 3, divide both sides by 3, I have a current of 1 amp. So what happens to current now if I increase my resistance? So if I go to 6 ohms and I rewrite that, I would have the same voltage equals the new current times my new resistance. Well, now this has gone up. So what has to happen to current? Well, if I solve for I, now divide both sides by 6, I see that I get a current flow, sorry, I'm sliding off the page here a little, of a 1/2 amp. So in the relationship between current and resistance, if I increase the current, I go from 3 to 6 ohms, or increase the resistance, 3 to 6, more resistance, less flow. My current goes from 1 to a 1/2 amp. So we can say, in summary, I and R are inversely related. Because as I increase the resistance, I get less current. In the same hand, if I decrease the resistance, I make it easier for flow, I would get more current for the same amount of voltage. So there is a way we can get Ohm's law from the data from the lab. The relationship that we get, V equals Ri, or often written V equals IR, either way. And then how are the different variables related? V and I are directly related, V and R are directly related, and then I and R are inversely related. And that's an intro to Ohm's law.